Alright, in the last chapter, we have discussed how to define the global attribute. Now assuming everything is ready, now we can start creating a sheet metal part. So in this chapter, I'm going to introduce how to create a base and the various flanges. Okay, first is creating a base. ZW3D provides three types: extrude tab, extrude flange, and the revolve flange. And you can continue to add more flanges based on it, which we will cover in the rest of the chapters. Then you can see the thickness will inherit from the global attribute unless you set it dynamically. Next, I would like to introduce the full flange. As its name implies, it can add full face flanges to multi-edges of a sheet metal part. Besides, both simple and S-bend are supported, and it can resolve the flange interference if there is. And sometimes the full flange cannot meet the requirements, so ZW3D provides profile flange and a partial flange. For flange with profile, as its name implies, it can customize the flange shape by redefining the sketch. Okay. As for the partial flange, similar to full flange, only difference is the flange will not cover all the selected edges. Instead, you can decide the length range, like from start to width or start and end. Next is the HEM flange. Normally it's used for making the mechanical joint on the end of the sheet metal to increase the anti-scratch hand treatment. One of the typical cases is the door hinge here, and it can connect the door and the frame. And the ZW3D provides multi-bend types like closed, open, closed loop, open loop, centered loop, S-bend, and curl. And they will greatly improve your working efficiency. And the next one is lofted flange. And there are three types for customer to create lofted flange: general lofting, flattened lofting, and bending lofting. For the first one, general lofting, it will create a thin-walled part and is unflattenable. It's similar to the loft feature in the solid modeling module. And the second is the flattenable lofting. This kind of flange can be flattened and manufactured by forming methods like press die. And since it's flattenable, there must be a gap inside. And the third type is bending lofting. Similar to the second one, it will create a flattenable flange. But the difference is, in this case, the manufacturing method is bending instead of forming. As you can see in the figure below, it will bend many times to create such a lofting shape. And there are four methods to define the bend quantity. The first one is to define the maximum arc height. Here you can see it will calculate the height of the arc. And the second one is number of bend. This one is easy to understand. We just define how many bends do you want. Like in this case, it's 6. 1, 2, 3, 4, 5, 6, right? And the next one is the maximum chord length, which is the arc length of the bend. And the last one is to define the maximum arc chord angle. And it's easy to understand. It will calculate the bend angle here. And when the angle is predefined, the bend quantity is also set. Okay, but frequently used is the number of bend. It's more easy to understand. And the next one is swept flange. It will create a flange feature that has the same section profile. So in this case, you will need an open profile and you will need a path. And the path should be perpendicular to the plane of the profile. And the next one is fold by line. As its name implies, we can use the command to create a bend along a line. And the last one is jog. We can use this command to create 2 bends and 2 flanges along a line. Okay, now let's move over to ZW3D to show you more details. Okay, first let's create a base tab. And here we will need a sketch. Okay, and here we can draw a simple rectangle here. Okay, now exit. And you can see the preview. And the thickness will inherit the global attribute. Okay, and sometimes we may create more base tab. For example, we create another one. And we just draw some polyline. Okay, now it's done. And here you can see we can check the option merge with the base and select original base. Then you can see it's merged into one. Okay, this is about the extruded tab. Okay, next I will show you how to extrude a flange. We select the command from the drop-down list. Okay, and then we create a profile. And it's available for both closed and open profile. So here first we use the closed profile. And you don't need to create a fillet. We can just exit the sketch. And here you can see it will create the bends automatically. And then you can see all the global value is inherited. And also you can change the height of the flange, the start or the end. What's more, you can create a rip directly. For example, we can select the point and the rip size. Okay. Okay, now you can see the rip is created. It's very convenient. You don't need to create a gap in your sketch. Okay. And next, I will show you the open profile. Okay, we create a new sketch in the XY datum, and then we can create an open profile. For example, here we just create a random profile, a simple one. Okay, now we exit. Okay, we extrude. Okay, now you can see the result. Also, all the bends will be created. And we can click OK to get the final result. Okay, next I will show you how to create a revolved flange. It's similar to the revolve in the solid modeling, but with a thickness. Okay, first we create a profile. We just create a simple one. Okay, and then we exit. And here we can choose a revolve axis. We use the Z-axis. And besides that, we can also create the start and end range. For example, we create a half. Okay. Okay, one more thing about the revolve flange is it cannot be unfolded. Here we can try. And then you can see it will fail. Okay. And after base creation, next I will show you how to create a full flange. We open a file. Okay, this one. Open it. Okay. And the step is as below. First, we need to click on the full flange. Okay, and here we can choose one or multi edges. For example, here we create one and another one. Okay, now you can check the preview. Okay, and there are more settings we can check. And for example, the position I have described in the attribute tab. And here you can see the different position options. And actually here we can cancel one edge to see more clearly. Okay, now we can change angle. Okay, here you can see the first one is material inside. See the effect. Okay, and the material outside, you can see it will lift, and the material natural, or you can make an offset based on the natural. And the last one is virtual sharp. You can check it. And it means the virtual sharp corner of the outer bent face should locate on the opposite edge of the selected edge. Okay, you can see that's no problem. And also we can check the height of the flange. We can type it manually. Okay. And for the bend type, it can be simple or S-bend. And it's clear for the S-bend, we need to set more parameters. For example, the height and the length. Okay, and here we can change back to the simple bend, okay, to see more parameters. Okay, and for the length type, there can be different types. And it's easy to understand. It will measure from different start and end point. Okay, and for the length, can also customize it. Okay. Okay, next option is trim adjacent bends. It means it will trim the bend which is next to the flange you are about to create. We use another area to show you. Okay, here you can see the bend next to it will be cut. You can see it will be cut, and if you uncheck it, it will not be cut. Okay, that's the meaning of this option. Okay, you can see more clear. Okay, this is the cut result. Okay, and we can see more options. For the key factor, I already show you in the attribute tab. Okay, so we will not spend so much time to repeat it. Okay, we just keep it by default. And here you can see the relief. We can check it. Okay, we can check it. We change the position type, and we can check on it. You can see, change it to none. You can see the result. And we can change to another, like a rectangle. You can see the result is different. And of course, we can set some ratio or absolute value here. For example, we change the value to 1. You can see it will be wider. And the depth, we can also change it if you want. Okay. Can change it bigger, like 1 millimeter. Okay. We can apply it. Okay. And there's another option, which is to extend relief. Here you can see we can select whether to extend or how. For example, to edge, it will extend the relief to the next edge, right? And if you check through all, it will stop until the next bend, right? Okay. And we can change a value. For example, you can change it bigger. You can see it's manually input. Okay. And we apply it. And here we can check more details. It's about the relief. Sorry, it's about interference. Okay. For example, if you create multi flanges, sometimes there will be a relief area. For example, here we change the angle. Now you can see two flanges interference with each other. So we can check it to avoid interference. Okay. And also for the interference gap, We can also manually type it. Okay, we can apply it. Okay, this is the result. And there is another option, which is close corner. Here we can check it. You can see the corner has been narrowed. Okay. And here you can see we can choose whether to meter the corner or not. If we uncheck it, we can check the result after unfolding. Okay. Okay, we can unfold it. We just select the shape. And we select the stationary face and also the bends to be unfolded. Okay. Now you can see the flange is linearly connected, right? Because we do not check the meter corner option. Okay. So we can redefine it. We can check on the meter corner option. Okay. And now you can see the flange is tangentially connected, right? So that's the meaning of the meter corner. Okay. And for the relief, you can check there are 4 relief types, like circular, rectangle, and the U cutout, and also V cutout. We can choose as required. Also, there are some parameters to adjust, like the offset, angle 1, angle 2. You can change it by yourself. Okay. Okay, this is all about the full flange. And then next, I'll show you the partial flange. It can add a partial flange to the edge of a sheet metal part. Now you can see. And for the range, we can choose start with or start end. And then we change the values. Okay. And most of the parameters is similar to the full flange. Just one is different, which is relief for insufficient length. For example, for this area, actually there is no enough room to create the relief, right? And if you check it, it will occupy the bend to create the relief, right? This is the meaning of the relief for insufficient length. Okay. And next, I will show you how to create flange with profile. We open a new part. Okay, here you can see we already have one, right? And we can create a new one. Okay, we find the area. Okay, and similar as the last one, we create edge. Sorry, we select the edge, and then we need to edit the profile. By default, it's a rectangle, right? We can adjust the parameters of the rectangle. Like we can make it more narrow, and also we can add the fillet. For example, fillet here and fillet here. Okay. And we can check the length, like 22.5. And beside that, we can create like a circle to it. Okay, we can mirror it. One more circle. Okay, we exit it. Now you can see the preview. It's quite convenient to create some unnormal flanges. Okay. and the other parameter is similar. Okay. And next, I will show you how to create HEM flange. And we open a case, HEM, and this is a hinge. And for the hinge, you can see the rotatory part is made of the HEM flange. Okay, now we can open it to see how to create it. Okay, we already have one, and we can delete it to create a new one. Okay, first we select the HEM flange command. And here you can see we also have the full HEM and also the partial HEM, similar to the full flange and the partial flange. Okay, here we just use the full flange as an example. And then we select the edges to add the HEM flange too. Okay. And here you can see we have different types. For example, the open and the closed loop, also open loop, also centered loop, and S-bend, and the last one is curl. For the curl, you need to change more parameters to make it. You cannot just randomly input some values. For example, here we can make the radius. Now you can see the effect. Okay. And in this case, we just need the third one, closed loop. And here we can change some parameters of the loop. The length, we want it to be 0, and the radius 2. Okay, now it looks good. And for the other settings, it's similar to the full flange or partial flange. Okay, we can click OK to get a result. Okay, and we can get back to the assembly. You can see it's quite good, right? Okay, so next I will show you how to create a lofted flange. And also we open a new file, lofted flange. And here you can see we already have 2 open profiles, right? Now we click on the lofted flange, and 3 subtypes. You can see general, flattenable, and bending. Now let's see the first one. It's a general loft. Okay, we choose the profiles. Okay. And here you can see we have some settings. Here we can just ignore it and click OK. Now you can see the result. And it's not unfoldable. You can see it's just a shape. It's just a shape with a thin wall, right? That cannot be flattened. Okay. The next type is flattenable bend. And we can see the difference. Choose the profiles. Okay. And here we can choose the cut if you want, but here we have an open profile, so do not need it. Okay, and here you can see for this kind of the flange, we can unfold it. Okay, we can check the result. You can see that we can unfold it, and it can be manufactured by press die. Okay, and the third type is bending lofting. Okay, we select the 2 profiles, and here actually ZW3D will calculate the bend quantity by 4 types. First one is the arc height. For example, it's 1 millimeter by default, right? And we can change it smaller, and you can see there will be more bends, right? And the second method is just direct. We just define the value of the bends. How many bends do you want? Here we select 6. and we can check it. You can see there will be 6 bends per side. Okay, and also you can define it by some other methods like the arc length and the arc angle. Okay, but mostly used, I think, is for the second one is the value. Okay, now we can unfold it to check the result. Okay, now you can see the result. Okay, this is all about the lofted flange. And next I will show you the swept flange. Similarly, we open a new file. And now let's see how to use this command. We need a profile and a path. Okay, and we select the stationary, the profile, and select the path end to end. The 4, 5, 6. Okay, now it's a closed profile. And also the other settings is similar. And also we can set the relief for this kind of flange. Then we can see the circular cutout. Okay, now we apply. See the result is quite good, right? And we can unfold it. Okay, this is the unfold result. Okay, let's open another case. Okay, we use the same method. We select the stationary and the profile. Then the path. We select it end to end. Okay. Select it. Okay. Now it's done. Okay, we can just click OK to get the result. Okay, pretty good. And more things about the swept flange. You need to know for the swept flange, there are 2 preconditions. First one is the location datum of the profile must be perpendicular to the stationary. We can check in this case, the angle is 90 degrees. It's totally perpendicular, right? If you change it, it will fail. And there's another precondition is the endpoint of the profile must be coincident with the one of the endpoint of the swept path, okay, or it will fail. We can try it. For example, we can drag it, lift the endpoint. Now you can see it will fail. Okay, so please remember the 2 preconditions. Okay, now let's just redo all the operations just now. Okay, and we can try a little bit to unfold this flange. Okay, unfold it. Okay, this is the unfold result. And the next one is fold by line and jog. Okay, we can open a case, fold by line. You can see this case. This is made by this command. Now we can make a new one. It's simple. We just select the line and also the face. Select the face. Okay, and here we need to change the position of the flange. Okay, the first one, this is good. And also, there are more position options. We can just use the first one. And for the angle, we can choose. We can also change it. For example, 30, 45 degree. Okay. Now you can see the result. It will unfold along a line. Okay. And the last one about the flange is the jog. Okay, we can open another case. We'll find the case, jog. Okay. This is made by jog. we can also delete it to make a new one. And for the draw, it's similar to the fold by line command. We can select the line and a face. It will make 2 bends. You can see 1, 2, 2 bends, right? 2 bends here. And this is basically how to use it. And we can see more options about it. Okay, the first one is the whether to reverse it. Okay, it's the reverse result. And also we have the height type, where to measure from, and also the height. We can change it. Okay, we can see the result. Okay, now you can see this length will be 10. It's 20 minus 10 is 10. Okay. And let's say more options. The last option is whether to keep the projected length. You can see now the length is here. The end point is here. And if we check it, you can see what will happen. Because it will extend the flange to meet the original position. But if we uncheck it, it will be the true length. Okay. And the other options is similar to the full flange. We will not introduce one by one. Okay, this is all for the creating sheet metal.